ONNX stands for Open Neural Network Exchange, and it is an open format to represent machine learning models. It is also cross-platform, so you can run it on any kind of device, and it also makes the model sharing very easy. And in this video, I will show you how you can convert almost any kind of PyTorch model to ONNX format and how you can create a Flask endpoint around it to serve it. I will be using the BERT sentiment model as a base model that we have trained in our previous videos. And if you have not seen those previous videos, then I've added the links to those in the description box. So I highly recommend you to take a look at those videos before you jump or before you come here. Or you can just watch this video and then take a look at those later on. So let's get started with ONNX. The first thing that you need is you need to install the ONNX runtime, and you can do that very easily using pip install ONNX runtime. I've already done that, so I won't be doing that again. So I'm just going to use the model that we have trained, but there is one small thing that I've changed. I have changed the max length of the model from 512 to 128, just because I just wanted to make some faster model training experiments. So that's the only reason I've done that, and except that everything is the same. So I will show you how you can convert this model, this BERT based uncased model, to ONNX format, and how you can use Flask API to serve it. Let's get started. So first of all, I will show you changes from the previous videos. So it's not many changes. Let me just increase the size of this a little bit more. Okay, I think that's perfect. So it's not a lot of changes. I'm on Torch 16, Torch 1.6 environment, but you don't need that. So you can still do it using the stable version of PyTorch. It's just for me. So if I look at the git status, I have modified this file called config.py. So I can just do a quick diff, and this is what I've changed. So I have changed the max length from 512 to 128. So I can now fit bigger batch size. So I've also changed the batch size from 8 to 32. So this is all the changes that we have now. And we go to our code base. So this is the code base that we have. And in this one, this is the training file that was there for a long time, right? You have seen that. So we will create a new file here called convert to ONNX. So we have trained our model in PyTorch. Now we just want to take the model that we have and convert it to ONNX format. So that's all we are going to do. We are not going to do anything else here. Okay, so we will just keep things quite easy. So the first thing that we do is we import from Torch import, and then okay, let's do that import first. So you can ignore the underlines here. Okay, so it's giving me unused import. It will be used. Import torch.onnx. So we import torch.onnx, and then we import the local stuff. So import dataset, import model, or from model. Let's say from model import BERT base uncased. And you can also import config. Okay, so this is what we have. Now we write the main function. So main, and inside this we can define some kind of device, let's say CUDA for now. And so whenever you want to convert a given model to ONNX format, you need to specify how the input would look like. Okay, and you can use torch.random to generate random inputs of the shape that you want, but you can also just use your own data loader that you have created. So I'm saying, okay, my review is, this is an amazing video. This is one of the reviews that I have. And now what I do is I will just call the dataset. So dataset, let's say, let's change this a little bit. From dataset, import BERT dataset. Fine. So now we have in dataset equal to BERT dataset, right? BERT dataset. Now we got that. And here we have review equals to review, and target, I think it was target, yeah. Target is anything, just a 0, doesn't matter. So we got that. And now we can try to convert this to ONNX, but first we need to do a few more things. We also need to call our model. So I will just say model is BERT base uncased. But when we train the model, we trained it using data parallel. So model, we need to convert it to data parallel again. Data parallel model. And then we need to load the model weights. So model dot load state dict, and we have torch dot load, and inside this config dot model path. So our model path is defined in config where we saved it. So we got almost everything. We can put the model in eval mode, which is not required, but we're just doing it. And let's print the model. Now we need the inputs. So to see the inputs, we go to our model and we see that our inputs are IDs, mask, and token type IDs. So let me just copy this thing from here and paste it in this line. So we need IDs, we need mask, and we need token type IDs. So my IDs will be just the first element of the dataset because there is only one element, and then IDs, right? And similarly we have mask and token type ID. So when you look at BERT dataset, it's returning IDs, mask, token type IDs, and targets, right? And that's what you have. So your inputs are IDs, mask, and token type IDs. So you got IDs, and here comes mask, and this will be token type IDs. Awesome. But there's one more problem. This should be a batch, right? So you have to add unsqueeze 0th index. So now it converts it to a single batch. And then we call torch.onnx.export, and we can write how we export the model here. So we have model, and you have 3 inputs instead of 1. So if you have 1 input, you can just write the input name here. So let's say if my input is IDs, so I can just write IDs here, but we don't have that. We have 3 inputs. So IDs, mask, token type IDs, and the order is also a little bit important here. So remember that, and I will write export it to model.onnx. And then we need some more things, like we need input names. So what are the names of our input? And this is a list. So our input names are IDs, mask, and token type IDs in the same order as we wrote the inputs. And now we have output names. So it can be anything that you want. Let's just call it output. And then we define one more argument called dynamic axis. So dynamic axis is a dictionary. And in this dictionary, what you have to do is you have to say which of these inputs or outputs have dynamic access. So dynamic access is like you can have batch size of 1 or you can have batch size of 10 or 32 or whatever, right? So we just define that. So 0th index batch size. So this is the batch size, which is dynamic in nature. And then we have mask, and the same for this one, mask. And then we have token type IDs, and same thing. And similarly for the last one, which is output, and you add the same thing here. Awesome. So do we have anything left? No. So I think now we are good to go, and we can run this code, and probably it will convert our model, torch model, to ONNX format. Let's see. So I'll just go to source directory and I will run convert to ONNX, and let's see what happens. So it's running, so it's going to convert it to using data parallel, then it loads wait, so it's a little bit slow. So you can see the whole model here, right? And if I scroll up to the top of it, it's wrapped in data parallel module. So the problem is Torch ONNX won't support data parallel objects. So you have to make a small change. So instead of model, you can just do model.module. So now you don't need to do that if you have not used data parallel to train your model. So if you don't have data parallel here, you don't need to do model.module, but you have data parallel, just go and print the model and see what you have. It's probably going to be module inside data parallel, so you just convert that. That's it. And we run the code again. So now it should work, and we should have our model. Okay, so now it seems to have worked, and if I do ls, I have model.onnx. So it has converted our model to the ONNX format. Now the next step is to make predictions from this ONNX model, right? So I will create a new file. Our previous file to serve the model was called app.py. So this will be app_onnx.py. And I'm going to app.py and copy everything. But before I copy, I would like to make some changes here, because we want to compare the time of requests. So I have joblib memory, which I was using as cache, and I'm going to remove all that stuff. I'm going to remove everything which is cached. Okay, and I think that's fine. I don't even need this one, so everything is okay. And now we can try to run it, but let's do that later. And I copy everything that I have in app.py to app_onnx.py. So now there are a few things that I don't need. First of all, I don't need these. So model won't be loaded in the same way. So one thing that you need here now is import ONNX runtime as ORT, let's say, because that's the most general way of doing that. And you got that one, and now what we need to do is we need to specify a session. So ORT dot, so instead of model equal to none and then loading the model, we have ORT dot inference session. Okay, and inside that you have model.onnx, so path to the ONNX model. So we got that, and we what we don't need is sending this model to device and this output. We don't need this output, and there will be something to return, but in the end, you don't need device CUDA thing. I think you don't even need the prediction dict. I was using it for caching. And let me remove the prediction dict from here too. And now you have okay, sorry, app.onnx.py. So now you have to create a dictionary. So it will be simple, like inputs or ONNX inputs. Okay, ONNX input, and it's a simple dictionary, but there is a catch, and I will come to that. Let's first create a dictionary with the same names. So IDs, mask, token type IDs. So this will be IDs, and then you have mask, and this is mask, and token type IDs, and this will be token type IDs. So now you have the ONNX input, which is a dictionary, and where the keys are the names and the values are torch tensors. But ONNX doesn't accept torch tensors, so you have to convert it to numpy arrays. So you can write a simple function, def to array. So this is taken directly from PyTorch documentation. So I will just use the same name to numpy, and here you have a tensor, right? And you say return so you can do something like this. If tensor dot requires grad, return tensor dot detach dot CPU dot numpy, assuming that it's on GPU. Else just return tensor dot CPU dot numpy. You don't even need the else, because if it's this condition, then you're returning, else you just return this one. Okay, so that's what you have to do. And here I will just add this function to numpy for all of them. So I have one here, here, and here, and I need to close the brackets. And save it. So you also see that how when I save it, makes it look good, and this is done using black formatter. So you can take a look if you want in one of my previous videos. And this becomes your ONNX input. So this dictionary, simple. And now what you have to do is get the outputs from the model. So output will be model.run, first argument none, and then ONNX input, and then you can print the output or return the output. So instead of starting this flask here, we can just do a simple sentence prediction. And so I take this function which takes just one input, the sentence, and I write a sentence like awesome video, and I can go to my terminal and try to run this and see what happens, if it's returning anything or not. Yeah, okay. So I get a list. Inside that I have arrays, right? So because the batch size is 1, so to print the actual prediction, I have to 0 0. And I get this one, which is fine. So now 4.94, and previously I was getting the same thing, right? 4.94. So what we have to do now is we need to apply sigmoid to it. And for applying sigmoid, we can either convert it to a tensor and then apply a sigmoid, but we can do something simple and write our own simple sigmoid function. So I will say def sigmoid x return 1 divided by 1 plus math.exp or np.exp, whatever you want to use, minus x. And this is our sigmoid. So sigmoid. And let's see. So 0.9929, so which is positive sentiment. And now we need to just plug it in. So instead of doing the print, I'm just going to do return. Okay. And now we can also start the API. So let's change it a little bit. So what I'm going to do here is I'm going to say host is 127.0.1. So it's running on localhost and it's running on port equal to 9911 9901 and debug. Okay, that's fine. And I'm gonna copy this same thing. So 990, let's 01 is our ONNX app, ONNX API, and going to do the same thing in here. In the old API, instead of app.run, I have 9902. So that becomes my old API. So now I can test both of them. So let me start these two APIs in the background, and then we can test it using curl request. So you see, like right now I don't have any caching, so all the predictions have to be made, so there is no caching at all. And okay, I think this looks good, and I will start the API now. So to start with the APIs, I have created this new terminal. So I have two new terminals and they all have the Torch 16 environment. So I'm going to run the first one, which is app_ONNX. So the new one. So it's running on 9901 and it took like a second to start. And I'm going to run the other one. So this will be app.py. This is the old one. And you see that it takes a little bit of time to load everything. I hope it's going to start soon. So now it's there. But you see, ONNX took a second. And then we go to this terminal and we can create a request. So I have already created a request which says this space is space awesome. And now we are going to check on 9901 and see how much time it takes. So it took 0.23 seconds to fetch this request, but we will do multiple requests because the first one always takes a little bit of time. So now it's taking 0.2 seconds. So it's taking around that 0.2 seconds. And we can do it on the old endpoint and it's taking 0.08, 0.04, 0.03 seconds, 0.03 seconds, 0.03, 0.04 seconds. So it's because it's running on GPU. So let me fix that. So I will change the device to CPU, and here we have to do one more thing, torch.load map location and torch.device inside that device. Okay, so this is what I've changed. I've added this parameter and my device is CPU now. So I will go back to app.py and cancel this one, and I will start a new one again CUDA visible devices, nothing, python app.py. So now it's running on CPU, so it's not using my GPUs anymore, and now we can have a fair comparison between the two. So let's do the request again. This is awesome. To the old one, and 0.17 seconds, 0.16, and to the new one, let's see how much time that one is taking. So 0.16, 0.17. So it's kind of taking the similar time. I actually expected it to take half of the time, but that's not happening. So this is like one of the ways you can convert the model to ONNX format. So I hope you liked today's video, and there's a lot more you can do with ONNX. I've left a lot of things here, and you can do a lot of other optimizations to make it even faster. So take a look at those, and now you will be able to serve your model using CPU, and you will be able to distribute it to any kind of environment you want using ONNX. So that's it for today's video, and I hope to see you next time. If you like the video, click on the like button and do subscribe if you haven't subscribed yet. And if you have suggestions or comments for this video or suggestions for the future video, let me know in the comment section. And thank you very much. See you next time. Bye.